Hello guys, welcome to our class for today. This is Normal Math Science Tutors Online, and you are welcome to our physics class for today. I remain Notable Michael, and please, if you have not subscribed to this channel, please subscribe. Click on the notification button so that when we upload a new video, YouTube will notify you. You can also reach us through the WhatsApp number that is showing on your screen. Please give us a like, and also you can comment on the comment section below. Please, for us to start our class for today, I want you to get your writing materials ready and be settled. So today we are going to be introducing scalars and vectors. Scalars and vectors. So right away, we go straight to our class. Scalars and vectors. So what are scalars and what are vectors? Okay, so a scalar quantity in physics, most quantities that are measured, they have just magnitude, right? So some quantity has just magnitude, as such quantities are known as scalar quantities. So most measurable physical quantities in physics have only numerical values and are completely described when their magnitude or sizes are known. Okay, so like if you are talking about length, you are just looking at the value of length. You are talking about mass, it's the same thing. Volume, density, time, speed, temperature, and energy. These are examples of scalars, right? These are examples of scalars. So these numerical quantities which have only magnitude but no direction are called scalar quantities. So examples of scalar quantities are length, mass, volume, density, time, speed, temperature, and energy. There are other examples that you can also find out from your various textbooks. Is that okay? So scalar quantities are those quantities which have only magnitude but no direction. Like if you are talking about mass, you can just add mass together. So these quantities are easily added or subtracted. Like if you have two masses, right? If you have two masses, you can just add it. Like this is 40 kg plus 50 kg. If you add it, you have 90 kg. So this one does not have direction. It's only the quantity or the value that is applicable. So these quantities are known as scalar quantities, right? Then vectors. Other quantities in physics has both magnitude and direction. So the quantity that you can describe with their magnitude and direction in a specified direction, they are known as vector quantities. So vector quantities are those quantities which have both magnitude and direction. Examples of vector quantities you have like displacement, velocity, acceleration, force, momentum, electric field. All these are examples of vector quantities. You cannot add vector quantities the way you add scalar quantities because they have direction. So they are added by geometrical methods, right? They are added by geometrical methods. It's either you use Pythagoras theorem to do the addition, depending on the question that you are looking at, or you use other geometrical method to solve them. So for vector quantities, they take into consideration the magnitude and the direction of the force. Also, calculations for vector quantities depends on whether the vector is acting in a straight line or at an angle to each other. So depending on the variables or the direction in which the vector is acting, that is how the calculation is also carried out. So this is just a brief introduction to scalars and vectors, or scalar quantities and vector quantities. Is that okay? Okay, the difference between scalar quantities and vector quantities are scalar quantities, they have magnitude or just numerical value. They are added by ordinary algebraic methods. So scalar quantities do not have directions, they just have only magnitude. So what about vectors? Vectors are both magnitude and direction. they are added by a geometric method. That is what I just discussed earlier on. So this is the difference between scalars and vector quantities. So how do you represent vectors? You can represent a vector quantity by a straight line with an arrowhead showing the direction of the vector, because we said that vector quantity has magnitude and direction. So when you write the magnitude of the vector, you represent it with an arrow line that has an arrow, a line that has an arrowhead to show the direction in which that vector is acting. And then if you are doing your calculation by scale, you draw the line that is proportional to the magnitude of the vector. Depending on the calculation that you are carrying out, you draw the line that is in proportional to the magnitude of the vector. So, for example, if you are talking about a distance of 300 kilometers due east, this can be represented by a straight line, right, that is drawn, and the straight line must face the direction of east. So if you want to represent that, you draw, since if this is your starting point, let's say this is your origin, and you see a distance of 30 kilometers due east, you represent it with a straight line pointing towards the eastern direction. Then you put the magnitude of the vector there. The magnitude of the vector is 300 kilometers due east. So if this is your origin O, and maybe this is point B, 300 kilometers due east, you represent it with a straight line showing the direction of the vector due east. Is that okay? So that is how you can represent vector. Okay, so this is what I just said now. This is your straight line due east. This is your due north. So 300 kilometers due east, it can be represented like this. Now, if you have a vector, say a velocity of 50 kilometers per hour in the direction north 60 degree east, this can be represented. You have to draw, since they said north 60 degree east, you can draw your 4 cardinal point, but you draw the northern direction and then the eastern direction. Since it is north 60 degree, it means you are taking the direction from the north towards the east. The direction is coming from the north towards the east, so this is north 60 degree east. So you draw it and then you put the arrow. This arrow OP shows the velocity of 50 kilometers, right? So this is how you can represent a vector. This is how you can represent a vector. Depending on the direction that is given to you, that is what you will use to represent the given vector. So this is north 60 degree east or 60 degree north of east. This is 60 degree north of east or north 60 degree east. So please, when you see any problem that has to do with direction of vectors, you should be able to represent it or know how to write the vector or interpret the vector notation that is given to you. So this is just a brief introduction to vectors. This is a brief introduction to vectors. So guys, this is where we are ending this class, this introduction to vectors. Please, if you have not subscribed to our channel, please subscribe to our channel. Click on the notification button, then click on the bell that is ringing, so that when we upload any new video, YouTube can notify you. Also, give us a like, give us a comment, so that we'll know how you are feeling, and then so tell us about our lectures. How are you enjoying them? Just give us a comment. We'll attend to all your comments, but let your comments be encouraging. Is that okay? So thanks a lot. You can reach us through the WhatsApp number that is showing on your screen. This is Noble Mind Science Tutors Online. You are warmly encouraged to continue to visit our channel. Right, so see you in our next class. Thanks.